Okay, my young urban mathematicians, let's go ahead and take a look at prime factorization. Now, in the earlier videos, we talked about the concept of multiples being broken down into smaller things we call factors, and that was the idea behind prime and composite numbers. We then extended it out, and we talked about what a prime number was, what a composite number was, gave them some examples and some reasonings why these examples support that it was a prime number or composite number. Now what we want to do is we want to go ahead and turn our energies towards prime factorization. So let's give you some numbers. And we'll do some very basic numbers. So we'll use 24 since we're using that one. And we'll use 86. Just two numbers I kind of chose randomly. So I'll reach in here and grab another dry marker. So let's go ahead and do prime factorization. When I'm doing prime factorization, once again, I'm taking this larger multiple. And what I'm doing with that larger multiple is I'm breaking it into smaller pieces, and I'm trying to break it to its smallest components. Remember the idea we said about this factor microscope or whatever? So in a sense, we're going to take that factor microscope and break these down to the very smallest pieces, and then put those smallest pieces down and let people know how many of those small pieces that are needed to go ahead to make this larger thing here. So let's go ahead and take a look at this. So we get our microscope out in a sense, and we begin to adjust using our multiplication skills. So we'll go here. I think for most people it'd be quick to just say 2 times 12. So I'll do 2 times 12 here. I'm going to stop here and circle this one. The reason why is because this number is prime. As you heard in the earlier video, you know why it's prime. So we're going to continue on. So I'll go here. I'm not going to circle this number because, as you understand from the last video, this number is actually a composite. If you run into a composite number when you're doing prime factorization, you must keep on going until you end with a prime number. So let's do so now. So I'm going to continue on from here. I've got the product up. Let's try 3 and 4. Could I have done 2 and 6? Of course. I would have gotten the same answer. Remember, multiplication is commutative, so it really wouldn't matter how I laid it out. I chose this route here just to do a little different thing, I guess. So I'll circle this number. Why? This number is prime. And as we said from the other video, you know why it's prime, so we're going to continue on. I don't circle this number here, and the reason why is because it's not prime. Okay, that means it's a composite number. So, because it's a composite, I'll continue on. 2 times 2. I'll circle those numbers right there and I'll stop. Why? Because those numbers are prime. And we talked in an earlier video why these numbers are prime. So let's go and take a look here. If we do our prime factorization 24, we can see all of our prime knuckles. Our prime numbers are circled, 2, 3, 2, and 2. And notice what are not circled are composite numbers. Composite number there. Composite number there. So if you're into interesting patterns or just ideas of things, you can always break down these numbers this way and realize the uncircled ones are composite, circled ones are prime. So I'm going to leave this alone before I talk about completely laying out the prime factorization of it and turn my energies towards number 86, or this number 86. I'm going to erase the composite here so I can go ahead and lay this number out with no issues. All right, so we've done prime factorization involving 24. Let's do prime factorization of this number here, 86. I'm just going to go ahead and divide this thing by 2, cut it in half. So if I cut that in half, that's going to be 4 and 3. So divide that in half, give me 4. Divide this in half, gives me 3. So then I have 2 times 43 here. At this point, this number is prime. This one looks like, can I break it down further? Can I not? I really don't have an idea here if this number is really prime. And if you're a youngster trying to do the math here, you're definitely a little nervous because you're like, man, that looks big. Can it be broken down? I can tell you, using a tip that I'll be showing you in the next video, that this number is prime. You can't break it down any further. Even though it looks large, there's nothing else we can do about it. So we circle this. So notice so far what we've done here. We've taken a larger number, a multiple. What we've done with that larger number, a multiple, is we've gone ahead and we've broken it down even smaller. in a sense, using our multiplication microscope or our factoring microscope. I guess you say a multiplication microscope. So using our multiplication microscope, we broke it down, 2 times 12. We realized that that number was prime. So then we went to this composite number here, and we used our multiplication microscope and broke it down even further, 3 times 4. We realized that this 3 here is prime. We looked at the 4 and realized it was composite. So we took out our multiplication microscope again, broke it down further. Bam, bam, right there. And so we notice a pattern as well, and you should. All my prime numbers, circle. All my composite numbers, uncircle. So we went over here, had 86, a larger number than 24, but realized that we could only find 2 factors of it. 2 and 43. This number is prime. This number is prime. So the reason why I laid out this problem for you to understand was for a number of reasons. One of the big reasons is that even though this number is smaller than this number, the number of factors are less on this side. That's a challenging idea sometimes because for many students, they think if the number is larger, there should be other larger things that comprise it. So it may be shocking for some of you to realize that, boy, that's 86, that's like 3 times larger, actually more than 3 times larger. But look, it only has 2 factors. Look at 24, it's more than 3 times smaller than 86, but it has 1, 2, 3, 4 factors. And if we can just include the multiples here, you'd say 6. Well, shouldn't say that. So 4 factors here in this situation. So just to make you understand that even though you see a larger number, it doesn't mean it's going to have a greater amount of factors, prime factors, or even factors than the smaller number. Notice here. All right, now I want to talk about this, but I'm going to cut this video so I don't want it to be too long. So we'll get right back to the same thing here, continuing a really important idea.